Welcome to the deep dive. We pull out the key nuggets of knowledge from important sources for you.
Glad to be here.
Today, we're getting into something really foundational in cloud computing, Amazon Elastic Block Store, EBS.
That's right.
It's often kind of invisible, but it's absolutely critical. The big question is, how do you keep your important data safe and, fast in the cloud, especially when your servers might just pop up and disappear?
Yeah, exactly. And our mission today is basically to unpack EBS. It's this persistent block storage for your EC2 instances. And we'll look at how it, well, totally changed the game compared to how things were before the cloud and what makes it so strong and flexible today.
Okay, let's jump in then. So fundamentally, Amazon EBS is a scalable, high-performance block storage service. It's built for Amazon EC2.
Mm-hmm.
You can think of them almost like virtual hard drives, right? You attach them to your cloud computer.
Exactly. Virtual disks.
And they store data in these fixed-size blocks. That's super important for things needing fast, low-latency access, like databases or even the operating system itself.
And what's really key, I think, is how EBS delivers that persistence. It's not like the old days with local disks.
Right.
EBS volumes are designed to be separate from the EC2 instances themselves. That's not just a minor feature. It's like a core architectural thing.
Mm.
It gives you that amazing 99.999% durability inside one availability zone because it's replicating data across different physical disks automatically.
Wow. Okay, so your data is safe even if the instance itself gets stopped or even terminated.
Precisely. And it handles high-performance stuff, low latency, high throughput. Plus, you can scale them up, resize them without downtime. And snapshots for backup, of course, huge.
It seems so fundamental now. I mean, it's hard to picture building anything serious in the cloud without it. What was it actually like before EBS? Let's say back around 2008. What were the big headaches?
Oh, it was. Tricky. Yeah, tricky is a good word. You were often stuck with local disks on the actual servers.
Yeah.
So if that specific piece of hardware failed, your data, poof, gone.
Yikes.
And early EC2 had something called instant store. But that was temporary. The data vanished the second you stopped or terminated the instance.
Ah, okay. Not persistent at all then?
Not at all. Backups, often manual, really slow. Think tape drives. Seriously.
Oh, wow. Tape.
Yeah. And encryption. If you noted it, you were probably building some complex custom thing yourself. Easy to mess up.
That sounds like a nightmare, honestly. So out of all those problems, what was the absolute #1 game changer that EBS introduced? What really solved the core issue?
Hands down, it was data persistence. The fact that EBS volumes live separately from the EC2 instances.
Right.
So your web apps instance could restart, maybe even crash, but all its data sitting on that EBS volume, totally safe, intact, no more losing everything because the server had a blip.
That independence is key.
Absolutely. And then right after persistence, you've got high performance. Right. With SSD options like GP3 or the IO2 volumes, you get super low latency, high IOPS. Perfect for demanding databases. Way, way faster than the old on-prem disks people were used to.
Okay, so persistence and performance are huge, but you mentioned scalability earlier. That was another big pain point on-prem, wasn't it? Adding storage was slow and expensive.
Oh, definitely. And EBS changed that completely. You can dynamically resize a volume, make it bigger, or even add more volumes to an instance, all through the console or API, no downtime needed. It's a massive improvement. Imagine needing more space, going from, say, 100 gigs to 500 gigs. You can do that in minutes.
That's incredible flexibility.
It really is. And for backup and recovery, those snapshots we mentioned, they're point-in-time backups stored in S3, which is Amazon's object storage. Super durable. Restoring from a snapshot is quick. Migrating data becomes easier. I remember, like you said, wrestling with tape backups back in the day. Snapshots felt like magic when they arrived.
I bet. And security. You mentioned encryption being hard before.
All right. Now, with EBS encryption, you just tick a box. It uses AWS KMS key management service keys to encrypt your data automatically when it's at rest. It just handles it. Takes away all that complexity and risk of rolling your own encryption.
So let me try to picture a real-world scenario.
Yeah.
A company maybe had a critical database on local server disks, always worried about hardware failure.
Yep, classic problem.
Now, they can just use, say, an encrypted GP3 EBS volume. They get the persistence, the high performance, easy snapshot backups, and they can scale it up whenever they need to.
Exactly. That's the transformation. It really underpins so many modern cloud applications.
Oh, okay. Makes perfect sense.
Yeah, so the key things to remember are persistence, that flexible performance with different SSD and HDD options, the high durability, easy snapshots, built-in encryption, and that dynamic scaling. It really just redefined cloud data storage.
So wrapping up, what does this really mean for you, the listener? Well, it means you get reliable, scalable, secure storage for your cloud apps. It takes away a ton of those old, complex infrastructure headaches, lets you focus more on building cool things, not just worrying about keeping the data safe.
And maybe a final thought to leave you with. Think about how this basic building block, this ability to reliably store data and scale it quickly, doesn't just help big companies. It empowers solo developers, startups, everyone. It's kind of the foundation that makes other cool cloud tech like containers or serverless really practical, because that temporary compute always has a safe, persistent place for its data to live. So what new kinds of innovation does this ease of data management actually unlock for the future? Something to think about.